has established a series of troubleshooting procedures for the R12 air conditioning system, which every technician should learn and follow in order to ensure proper servicing of the system. Although system configurations differ depending on the vehicle, the standard pre-service checks found in section 83.00 of the service manual apply to all vehicles. The process begins from the moment the vehicle arrives. Find out as much as you can about the problem from the person who uses the AC system, the driver. After getting a basic idea of the difficulty the driver is experiencing, start the engine, set the engine speed to 1500 RPM, and build up full air brake system pressure. Close the doors and windows and turn on the air conditioning, setting the controls at maximum cooling with the blower on high. If the vehicle is equipped with an auxiliary AC system, turn it on full also. Place a thermometer inside the center dash outlet. While this is in place, you'll continue with the remaining performance checks, leaving the thermometer in the dash for at least 10 minutes. Check for proper airflow from each vent. If the airflow is low, check for leaves and debris that might be blocking the air inlet. If that's not the problem, see if a duct has come loose or has collapsed. Check the blower motor to be certain it's putting out airflow on all its speeds. Blower motor troubleshooting, removal, and installation instructions are contained in the service manual, section 83.00. Visually check the AC belt to be certain it isn't slipping, and make certain the AC compressor clutch is engaging while listening for unusual noises from the compressor. With a Horton on-off fan, the AC compressor clutch won't engage until the vehicle air system pressure is above 65 psi. Carefully check all the AC system lines, starting with the discharge line at the compressor. It should feel hot. The suction line should feel cold. If the lines are warm, the compressor could be faulty, or the R12 charge in the system could be extremely low. Feel the inlet and outlet at the condenser. There should be a noticeable temperature difference, with the inlet being warmer than the outlet. The line from the condenser to the receiver dryer should feel warm. A cool spot could indicate a restriction. If the line is hot, the condenser isn't working correctly. The inlet and outlet of the receiver dryer should be the same temperature. If not, the filter could be plugged. The line from the receiver dryer to the evaporator should feel warm. An icy spot could indicate a restriction. Finally, the line from the evaporator to the compressor should feel cold. A warm line could indicate a bad expansion valve. An icy line indicates that the expansion valve could be stuck open or that the system has been overcharged with R12. If the evaporator freezes over, a thermostatic switch capillary tube may be bent, kinked, or mislocated, conditions which can also lead to other symptoms of other AC problems. Any oily spots on the lines or at the fittings could mean a system leak. Check the sight glass on the receiver dryer. Bubbles normally appear when the system is first started up, but should disappear quickly, although an occasional bubble may appear. A constant flow of bubbles could indicate that the system is low on R12. A clear sight glass normally means the system has an adequate charge. However, an overcharged system could also have a clear sight glass. A dirty or cloudy sight glass indicates a contaminated system. Oil streaks could mean an oil overcharge. Any moisture indicator color other than blue means that there is excess moisture in the system. Check the water regulator valve. If it isn't closing all the way, heat will enter the cab, giving the impression that the AC isn't working. Check the engine temperature. If the engine is running hot, the AC system will not be as efficient because the condenser will be picking up heat from the radiator. Compare the center dash temperature readings to those found on the AC troubleshooting chart in the service manual. If the reading is too high, the system isn't operating correctly. Shut down the engine. After the engine is shut down, feel across the surface of the condenser. There should be a gradual change in temperature across the face of the condenser. Any cool spots indicate a damaged tube. An oil spot indicates a leak of R12. Visually check the AC pulley to see if the belt is slipping or worn. This completes the Freightliner pre-service checks of the air conditioning system. If you discovered earlier that the AC compressor clutch wasn't engaging, remembering that the clutch won't engage until the vehicle's air system pressure is above 65 psi, check the voltage drop of the compressor clutch ground circuit. First, turn the key on with the engine off. With the blower motor on high and the AC control level at maximum AC, disconnect the AC clutch power lead at the connector at the compressor. Attach the positive probe of a voltmeter to the power lead. Touch the voltmeter negative probe to an unpainted area on the engine block near the AC compressor mounting brackets. Then touch the voltmeter negative probe to the compressor case as close to the clutch as possible. Compare the readings. They should not be more than 0.25 volts apart. If they are, the compressor isn't properly grounded to the engine. If no voltage is reaching the compressor clutch, check the thermostatic switch. This procedure is contained in the service manual. If the thermometer you inserted into the center dash outlet indicated a high temperature reading, check the refrigerant pressure in the system by connecting a charging station to the compressor's service ports. The station features gauges for measuring pressure on the low and high sides of the system. Before connecting the charging station to the compressor, review the safety precautions contained in the service manual. Failure to review these safety precautions and to be aware of the dangers involved when working with refrigerant could result in serious personal injury. Safety glasses and gloves must always be worn when working with R12. Begin the procedure by making sure both manifold valves on the station are closed. Connect the manifold hoses to the system service ports. Connect the red hose to the discharge service port, the blue hose to the suction service port, and the yellow hose to a recovery machine. After connecting the charging station, start the engine. With the engine running at 1500 RPM, the on-off fan turned on, the system on max AC, and the doors open, the low pressure gauge should read between 9 and 20 psi when the system is running. The high pressure gauge should read between 130 and 190 psi. Low gauge readings indicate the system is low on refrigerant. An extremely low charge will be indicated by lower gauge readings. Some gauge readings, examples of which we'll see in a moment, may indicate the necessity of purging or flushing the system. The system must be purged or flushed when it has been contaminated by excess water, oil, or dirt. Purging involves the use of a dry, inert gas, such as nitrogen, to blow out wet air, rust, or loose dirt from the plumbing. Do not use shop air. Flushing, which is reserved for extremely contaminated systems, involves the use of liquid R12 under pressure. R12 is pushed through the system and filters are used to remove contaminants. The R12 is returned to a refrigerant recovery station in a closed loop. No other substance but R12 can be used for this process. Check the service manual for detailed precautions and step-by-step procedures for purging and flushing the system. If there is some air and moisture in the system, pressure readings will be normal even though the air conditioning is providing insufficient cooling. Any leaks will have to be repaired. If there is excessive air and moisture in the system, the suction pressure will be high at first, then drop to a lower range, or indicate a vacuum as the system runs. The discharge pressure will run high. Any leaks will have to be repaired, and the system will require purging or flushing. If the condenser or radiator air passages are clogged, or if the system has been overcharged with refrigerant, both suction and discharge pressures will be high. The condenser and radiator fins must be cleaned, or refrigerant must be recovered, and the system must be recharged with the correct charge. If there is a restriction between the compressor and the expansion valve, suction pressure will be low, and discharge pressure will read normal to high, unless the restriction is between the compressor and the receiver dryer. in which case the discharge pressure will be extremely high. Damaged parts must be identified and replaced, and the system must be purged or flushed. If the expansion valve is restricting the flow of refrigerant, is stuck closed, or contains a malfunctioning temperature sensor, the pressure on both the discharge and suction sides of the system will be low, although normal pressures can be restored when a hot, wet rag is applied to the expansion valve. In this case, the expansion valve must be replaced. If the expansion valve is stuck open, causing flooding of the evaporator coil, the suction pressure will be high, while discharge pressure will be low. The expansion valve must be replaced. If the belts are loose or worn, if the compressor clutch isn't working, if there's an internal leak in the compressor, or if the pressure switches are not working, pressure on the suction side will be high and pressure on the discharge side will be low. Belts, engine drive pulley, compressor, clutch, or pressure switches must be replaced as needed. Whenever pressure is low on both sides of the system, or pressure is normal but the AC isn't putting out sufficient cooling, or the gauge readings indicate the presence of air and moisture in the system, you must check for leaks along all lines and fittings. Several methods are available, but Freightliner recommends use of an electronic detector, which produces an audible warning when a leak has been discovered. Pressurizing the system with dry nitrogen helps to find slow leaks. Other methods may be dangerous to personnel or damaging to the system. In this case, the technician has discovered a leak at one of the connectors on the receiver dryer. Before the leak can be repaired, the R12 in the system must be discharged into a recovery unit. Follow the recovery unit manufacturer's instructions to discharge the system. The cause of the leak was a torn O-ring, which the technician replaces. Whenever the charge is dropped from the system, the receiver dryer should be replaced. While the charge is dropped, check the oil level in the compressor. Instructions for a full oil change are contained in the service manual. Always replace the amount of oil lost during the recovery procedure and compensate for receiver dryer replacement. Before the system is charged, it must be evacuated to remove any water vapor. This is accomplished by lowering the system pressure using a vacuum pump, causing the moisture to vaporize at ambient temperatures. Check the service manual for detailed evacuation instructions. To be certain the system doesn't leak or contain any moisture, connect a thermistor gauge. This gauge measures the vacuum in the system in microns of mercury compared to inches of mercury, as indicated on the charging station's gauges. 1 inch of mercury equals 25,400 microns of mercury, obviously a much finer and more accurate method of measurement. If there is any moisture in the system, the pressure will rise. Continue to evacuate the system. If there's a system leak, the pressure will soar. Repair the leak. You're now ready to charge the system with new refrigerant. 2 basic methods are available: liquid charging and vapor charging. Before beginning either process, check the specifications tables for the required refrigerant quantity. Weigh the bulk container or use a graduated dial for a bulk container with a heater. Filling the container and turning on the heater during evacuation will speed the process. Be careful not to overheat the refrigerant. When liquid charging, open the container liquid valve and the manifold high side hand valve. Caution: do not open the manifold low side hand valve or start the engine while liquid charging, or the compressor could be damaged. When the system is fully charged, close the manifold high side hand valve and turn off the refrigerant supply to the manifold set. If vapor charging, open the manifold low side hand valve to allow R12 vapor to be drawn into the system while the compressor is running, with the engine running at 1500 RPMs. When the system is fully charged, close the manifold low side hand valve and turn off the refrigerant supply to the manifold set. Run the air conditioner at maximum to check the gauge reading and outlet air temperature. Refer to the specification tables in the service manual for the temperature-pressure specifications. Disconnect the manifold set. Finally, recover the refrigerant from the charging station line. This completes our look at the Freightliner pre-service checks and service procedures for the R12 air conditioning system. Because the use of chlorofluorocarbon, or CFC, has been recognized as a global environmental problem, the R12 system is scheduled to be replaced by the 134A system. New troubleshooting and service procedures have been established for the 134A system. For additional information about the maintenance and service classes and videos available from Freightliner, contact the Service Training Department in Portland, Oregon.